That's good, Code Milkers. Let's do the 12th day of the LeetCode 30-day challenge. Today we have last stone weight. We have a collection of stones. Each stone has a positive integer weight. Each turn we choose the two heaviest stones and smash them together. Suppose the stones have weight x and y, with x being less than or equal to y. The result of this smash is x is exactly equal to y. Both stones are destroyed. Okay, now I'm going to start taking some notes. The problem's getting a little more complex. This problem, we have array of stone weights, positive integers. Each iteration, choose two heaviest stones, so we have to sort it. Smash them together, which means get the... No, I don't know if it means difference. Could be adding. Let's see. Each turn we choose the two heaviest stones and smash them together. Stones have weights x and y, with x being less than or equal to y. The result of this smash is... I like the word smash for this. It's really funny. Smash! X is equal to y, and that means that both stones are totally destroyed. So I'm assuming they're popped from the array. If x is not equal to y, the stone of weight x is totally destroyed, so the first element, and the stone of weight y has new weight y minus x. Okay, that's a lot to digest. So smash them together. If x equal to y, pop both elements, else pop first element, second element is equal to second element minus first element. I could open the window. Okay. Where were we? Y minus x. So pop first element, and the second element is equal to itself minus the first. At the end, there is at most one stone left. Return the weight of this stone, or 0 if there are no stones left. If one stone left, return that stone, else return 0. Okay, so since each iteration I need the two heaviest stones, that's going to require a sort each time. So this isn't going to be the fastest algorithm. There's probably a faster way to do this, but I just want to get it done. So probably going to have to sort on each turn. So I'm going to go ahead and just make the sorting function right now before I forget to. So sorter, take A and B. And if A is less than B, return -1. Else if A is greater than B, return 1. Else return 0. That one should work. And we'll const that because it's not going to change. Okay, so in the creation of our problem, we kind of created an algorithm because the description of the problem was pretty algorithmic. It kind of gave us the answer just by reading it nice and slowly to understand each direction, which I love problems like this because they basically solve themselves. So let's go over data structures. We're obviously going to need a loop of some kind. We need a loop through the stones array. We need to have a variable to store the let's see, to store the difference if the weights are not the same. So if x is not equal to y, we need to store y minus x so we can reassign the second element to that difference between the two stones. Algorithm, we kind of already wrote it up top. The only thing I'd add to it is that choose the two heaviest stones sort. Before each iteration, I want to sort the array again, because I'm thinking that it could be when we take the difference of y and x, we could have a different element that's actually greater than that result, and we need to put that before the previous second element, which would now be the first. So just a hunch I have. Let's see. So we want to start off with if stones dot length is if it's equal to 0, we're going to return 0. And then let's create our difference. And before we enter the loop, well, no, we can just sort it once we get in the loop. Okay, while, what's our while condition? While stones dot length is greater than or equal to 1. Which, greater than 1. Because we don't, if it is 1, we want to break. We want to get out of that array. We want to get out of the loop. So first thing we'll do is we will sort the array. So we'll do stones sort sorter. And I'm going to put a break here. I want to see that it's actually sorting in the right way. Make sure it's not ascending. I want it to be descending. I think I made it ascending, so I don't have to switch the -1 and 1 in the sorting function. Yeah, let me just switch these up. Okay, let's see. Nice, okay, so the first two elements will be our stones to sort. Okay. Now let's do difference is equal to stones minus stones 1. If the difference is equal to 0, which means they're the same, and then we have our else case, which means that they're not the same. So if the difference is equal to 0, we want to take the first two elements out of that array. So we'll do stones shift. And I think that's all we have to do if they're the same, because they're both destroyed. Yep, okay. And now, if it is not equal, the difference, we want to shift the first, and then we will set stones 0, which is the new first element, which was the second element at the start of this loop. We will set that to the difference. And then here, we'll return, once we're out of the loop, so once the stone's length is less than or equal to 1, we'll return stones.length is equal to 0, and for that we'll either return 0, or if it's not 0, we'll return stones 1. Actually, no, 0, which is the first element. Let's see what we get if we just run this. I want to see if it throws any errors at first. Nice. Okay, that was 1. That's correct. Let's see what our stones array looks like on each iteration, so if we can see if it matches the test case. Yep. It matches. It matches. Let's try a couple edge cases, an empty array, an array with just 1, and then we'll just throw some random numbers in 1. And we'll see what we get. Okay, so stones cannot be an empty array. Good. And let's try one where the two stones are actually equal, so it should turn out 0 because the length is 0. So 2 and 2 are equal. Let's see if that gives us the right return value. Great. Let's see if it works. Nice. Accepted. The problem wasn't too bad. Okay. Mid-range speed, not too bad. Have a great day.